Good morning. I'm Scott Turner. I'm a visiting researcher here at Gobabeb. The plant you see at my feet here is Welwitschia mirabilis, Namibia's iconic plant, Welwitsch's wonder. It's an interesting plant in a lot of ways. Its evolutionary lineage, for example, traces very near to the origin of the flowering plants and the split between the gymnosperms, the cone-bearing plants, and the flowering plants, the angiosperms. What we're interested in here right now is how Welwitschia manages to live in a desert environment. Welwitschia are found throughout the Namib Desert, but they're also found in other habitats as well. One of the unusual things about Welwitschia is that it doesn't seem to have any of the typical adaptations that we associate with plants living in the desert. And yet, here they are in quite substantial numbers, and we want to know why. Now, Welwitschia isn't particularly economical in its use of water, and this is a paradox for living in the desert. It's got to be getting the water from somewhere, but where? For a long time, it was thought that Welwitschia got its water from dew or fog, but that seems no longer to be the case. It seems to have been disproved. So that leaves groundwater as a source for water. And yet, where's the groundwater? The unusual thing about Welwitschia is its large leaves. This is not something that we associate typically with desert plants, which tend to have very small and numerous leaves. And so we're wondering, does this have something to do with the ability of Welwitschia to live in the desert? One thing these large leaves do is provide an expansive area of shade around the plant. And we're wondering if that has something to do with Welwitschia's ability to manage water. Now, groundwater in this instance comes from rains, and these are very rare events in the Namib. Typically, we're talking about rainfalls on the order of 10 millimeters, and these quite infrequently as well. So what we're doing here is we are trying to do an experiment to see how Welwitschia responds to these very rare and transient inputs of water from rains. To test this idea, we've made this impromptu rainmaker here, and our aim is to put an amount of water into the soil that mimics a roughly 10 millimeter rainfall event. And then we want to see what happens to the water as time goes by. That little strip of flagging tape marks where we have inserted 2 temperature and humidity sensors into the soil. What we'll do is we'll use those instruments to measure how the temperature and humidity of the soil varies over the next couple of months. To mimic a 10 millimeter rainfall event, we have to add 1.5 liters of water over the area represented by this screen right here. And that's a very handy thing because Coke bottles and Sprite bottles come in 2-liter values, and we can just fill up a spray bottle with this and distribute the water that way. The way this simulates a rainfall event is we spray a fine mist onto the screen, and the screen gathers these fine droplets in the mist and gathers them together into larger droplets, and then these eventually fall to the ground, mimicking, we hope, rain. As we add the water to this, the droplets gather, the fine droplets gather on the screen. We have to tap it every once in a while, but these droplets eventually get large enough to fall off and down onto the ground in something that we hope resembles rain. And as you can hear, that's about 1.5 liters of water spread over this area, which mimics our 10 millimeter rainfall event. That was our simulated rainfall event for open soil exposed to the sun. Now we want to do the same thing for the shaded environment under the Welwitschia leaf. So we take our simulated rainmaker, we position it so that the center of it is right over the place where we have a similar array of sensors. We have another 2-liter bottle of water, which we will put into our sprayer. Fill it right up to 1.5 liters again, and we start spraying. Obviously this is imprecise, but that's what we do for fieldwork. So So there's our simulated 10 millimeter rainfall events, one in open soil and one under the leaf of the Welwitschia. What we're going to be doing is following the fate of that input of water over the next couple of months. If we follow what's going to happen in the open soil, the daily input of energy from the sun is going to act strongly to drive that water out and evaporate it into the air. What we're wondering is if the shady environment created by the Welwitschia leaves is going to help that plant retain water from that 10 millimeter simulated rainfall event better than it would in the exposed soil. And we're going to come back in a couple months and find out if our idea was correct. So that's what's happening at Gobabeb today.